Welcome back everyone. So today we will discuss about the energy of the nth orbit, electron of which is revolving in the nth orbit. And yesterday in last class also, not yesterday, in last class we are discussing that part, energy part, and all in this class we will discuss the speed of the electron in the nth orbit, and then we will go to the atomic spectra, which is very important. So we have already discussed, we have started from the Dalton hypothesis, then we discussed Rutherford atomic model, planetary model, then we discussed Bohr atomic model, and this is also the continuation, or we can say the application of the Bohr atomic model. So in last class we evaluated the form of radius of the hydrogen atom, and also the energy we have evaluated the forms, but we did not complete the part of the energy part totally. So let me start with again from the energy part, then we will go to the velocity part. So this is the fourth class of this chapter, atom chapter. So let me start. Okay, so this is energy of electron in the nth orbit. Okay, so we have evaluated the general form, right? What was the general form? The general form was En is equals to minus 1 by 4 pi epsilon naught E square divided by 2 Rn. This is for hydrogen atom, that is why there is no Z, because we know that for hydrogen atom Z is equal to 1. And now Rn is A naught n square, where A naught is the first Bohr radius, or in general it is said Bohr radius. The value is, what is the value? 0.53 Armstrong, correct? So now if we put it here, then we can obtain this part. We have already done in the last class, though I am doing so that we can make continuation properly. So it is A naught n square. This is general expression for the electron which is revolving in the nth orbit, total energy. Okay, so now from here we can write, what you can write? E1. Just we have to put n is equal to 1, then it will be minus epsilon naught E square divided by just 2 A naught. So you can see this total part is also constant, right? So this part is also constant, everything is constant here. So as everything is constant, so we can evaluate the value we have already evaluated in last class, which is minus 13.6 electron volt. Now if we put that here, then we can obtain it, because this part is exactly the E1. So now we can write it E1 divided by n square, and E1 is minus 13.6, so it can be written as minus 13.6 divided by n square electron volt. This is the value of the electron general expression which is revolving in the nth orbit for hydrogen atom, obviously. Okay, this correct. Again, if you remember, then we have also done these things, right? This expression also we have evaluated. If we put the expression of A naught, what was the expression of A naught? If we remember, what was the expression of A naught? It was epsilon naught A square divided by pi m square, and the value is 0.53 Armstrong, but expression was this. If we put this expression here, then we can obtain it E square divided by 2, n square is there, right? So n square is there, and it will be epsilon naught A square pi m E square. So let me do it for E1 first, so then there will be no n square. Okay, so it will be this. Now pi will be cancelled out only, and the rest of the part will be m e to the power 4, obviously minus sign, square h square. And again what we have done, we have multiplied with ch and divided with ch. So this was, and it can be written as RCH, where R was the Rydberg constant, right. So why we have explained this thing, right. Why we have done this? Because E has the energy, E is the energy, right, and we know the energy, we know that energy of unit of the energy is joule, but to convert it into the centimeter inverse or meter inverse, that means from energy to wave number, we did this trick. We have explained this part very well, right. Why we generally want to calculate this spectrum analysis, the spectroscopy basically in terms of wave number or unit of centimeter inverse or meter inverse, because the value, the experimental values are easy to deal with in this unit, centimeter inverse or meter inverse. That is why we have converted from the energy to wave number, and that is why this Ch was multiplied. Otherwise this part was also constant without multiplying by Ch or dividing by Ch, but to be convenient with the experimental data we have to convert it to wave number unit. That is why we did this trick. Okay. So this is U1. So generally what will be the En then? En is just E1 by n square. So En is E1 by n square and D1 is minus RCH divided by n square. So this is very important relation, that En is minus RCH divided by n square. Okay. So also we can see that the E1 is actually not E1, En is proportional to n square, but there is a minus sign. We have to keep in mind that there is a minus sign as well. So if n is increasing, that means that 1 by n square will decrease and En will increase because there is a minus sign. Okay, here is a minus sign, correct. So that is why. Okay, but if we consider the numerical value only, the magnitude, then En proportional to 1 by n square, correct. So this is the energy. That means if we increase the n, so energy will also increase. This is not magnitude, this is energy. We considering the minus sign as well, but if we consider the only magnitude, then it is correct. One thing we have to understand, for E1, I did not explain this in last class. This is 13.6 electron volt, but there is a minus sign, minus 13.6. What does it mean? It means that the energy is less than 0. So that means it actually means the stability. It signifies the stability. Okay, that means we will discuss this part very well when the ionization spectra, ionization energy will study. Let me clear it here as well. So if we remember, in E there are two parts, right? One is kinetic energy and another one is potential energy, correct. Kinetic energy was positive, but potential energy was negative, and overall energy is also negative. That means actually potential energy is greater than the kinetic energy, the magnitude. Obviously the magnitude is greater than the kinetic energy, then only what will happen, that overall U will be negative. So it means that potential energy means the number of the energy required to bring unit charge into the electric field of the nucleus. That is the potential energy, the description of the definition of the potential energy. And kinetic energy is the energy while the energy of the electron while rotating around the nucleus. So that will be essentially positive. But potential energy is negative. That means you give the energy to the electron so that it can revolve around the nucleus. Means when there is this things is also explained in the electrostatic chapter. Okay. What there is a, let us say there is a positive charge, any positive charge, forget about nucleus, any positive charge is there. Now if you bring any unit charge into the field of that positive charge, let us say this is the field, this is the field. So if you bring that positive charge in the field of the unit positive charge, this may be positive, this may be positive, this may be negative, this is unit charge. The definition is, in definition this should be +1, but this may be plus or maybe minus, does not matter. Here we are considering the, here we are considering any plus charge is there. Now this is the electric field. Now, if you bring that unit positive charge in the electric field of that this q charge, let us say q charge, then you have to provide the energy, okay, then only it will come, or maybe it can, let me write it clearly. So, what was the definition of potential? V is actually F dr minus infinity to r. So, this is the definition. This force is electrostatic force, okay. So, if both charge are positive charge, then the force will be negative, positive, and if there is a one is positive charge, one is negative charge, then the force will be attractive force, correct, and in that case the force will be negative. So, this is the case actually. So, when you bring one electron in surrounding of the nucleus is positively charged and electron is negative charged. So, it will attract, electron will be attracted by nucleus. So, what will happen, electron will automatically come, means you do not need to force electron to come around the nucleus, right, because it is electron is attracted by nucleus, it will essentially come and revolve around the nucleus. So, and that means electron will be stabilized, and if electron is stabilized, then it will emit the energy. So, that is why as energy is emitted from the electron, that is why the energy will be negative while rotating around nucleus. So, what is the conclusion? Let us say this part is very crucial, you have to understand this, okay. Let us say there is a nucleus and this is the any orbit around the nucleus, this is any orbit. Now, there is one electron, free electron, that is roaming about, okay. So, the energy of the electron will be 0, potential energy. I am not talking about kinetic energy, just potential energy, focus on the potential energy. Potential energy is 0. Now, if that electron is bring to here, let us say the electron comes around the nucleus while roaming about, and now what will happen, the electron will be stabilized because it has entered in the electric field of the nucleus, okay. That is why electron will be stabilized, and what will happen, as electron is stabilized, electron is attracted by the nucleus, as it is stabilized, it will emit the energy, it will release the energy, okay. In physics actually, as much you get stabilized, your energy will be decreased, this is the fact, okay. Now, that is why what happened, the energy will be negative, here is 0. So, now if it is decreased, then it should be less than 0, here the energy should be less than 0. So, you may ask why we are considering this is 0. So, that we can say this is the convention. For a free electron, we are considering the potential energy is 0 for free electron, that is the case, that is the convention, because there is no field, there is no electric field. So, that is why we are considering that 0, as that is 0. So, when it comes in a electric field for nucleus, because nucleus is positively charged, then it will be stabilized and the energy will be decreased, and if as it is decreased from 0, it should be negative. That is why potential energy of electron in any orbit is negative, it is less than 0, it should be. That essentially means that electron is get stabilized, okay. Now, if there is a negative charge, let us say consider there is a negative charge, and that has also electric field, and now the electron is also, that electron is roaming about there also. Now, electron will not come, because if it approaches to the field of the negative charge, this charge q charge, it will repel, negative charge will be repel the electron, because both has the same charge, we know that same charge will repel and opposite charge will attract. So, now in that case you have to give the energy, so that electron can come there, electron can reside there, you have to put the energy from outside, then only it will come. This was the basic definition, right. So, in that case you have, as you have to give the energy of the electron will be increased, the potential energy of the electron will be increased, and that will be greater than 0, because previously it was 0. Now, you gave the energy to the electron, so that it can held in around that centered q negative charge. So, in that case the energy will be increased and it will be positively charged, positive energy, not positively charged, the energy will be, potential energy will be positive. So, if potential energy is 0 for any electron, that means that is a free electron, there is no electric field around the around that electron is totally free, it is not it's not roaming about under any electric field. Now if there is a positive charge, it has electric field, and if electron is roaming about around that positive charge under that electric field, then the energy of the electron will be decreased due to the attractive force, which makes the electron makes the energy of the electron less than 0, because it will be decreased, and that means the energy will be negative, the energy will be less than 0, negative. And if the case is reverse, if there is a negative charge, then it will repel the electron will not come automatically around that negative charge. You have to force that electron, you have to give the energy, so that electron goes around that negatively charged center. So that's why in that case you have to give the energy, and that's why overall potential energy will be greater than 0. So we can write it briefly that if the potential energy EP for any electron is greater than 0, that means it is unstable, because you gave the energy, right? Then only it will revolve around the negative charge. It does not want actually. EP is 0, that means it is a free electron. There is no electric field, no control of electric field on that electron. It can move accordingly, it is totally free, no force is there, no attractive, no repulsive force. Now if there is attractive force, then it is less than 0, it is stable. So that is why in case of atomic structure, as there is a nucleus, which is, this is valid for any positive negative pair, charge pair, not specific for the electron proton. Okay. So that is why what happened for in atomic structure, the energy is less than 0, is minus 13.6. Okay. So as much now n increase, 1 by n square decrease, En will also increase, that means energy will increase. Okay. But numerical value obviously decrease, because there is a negative sign. Now I think it is clear. Okay. So now in general we can write En is equal to minus RCH by n square. So it is nucleus, this is, let us say, E1, this is E2, it is not spherical but it should be spherical, E1 E2. So E1 should be less than E2 and both should be less than 0, correct? It is clear. So now, but one thing we have to remember, that the energy gap between the energy level also depends on the n, that is not fixed, that is also depends on the n, that we have to find out. Okay. So what will be that? Let us say daily between n plus 1 minus n, then it will be RCH, let just n, correct? This is, so negatively charged, negative sign is absorbed, then it will be n square. This is just basic algebra, it will be n square 1 to n minus n square will be cancelled out. Correct. Now if n is very high, let us say, though not we have, okay, forget it, n is not high, this is the fact. Now here if n is increased, if n increases generally, then what happen, this is the numerator and this is the denominator, which will dominate. Here is square, in denominator there is n square, n plus 1 square. So clearly the denominator will dominate, and if denominator will dominate, that essentially means that daily will decrease, because there is no negative sign, that was absorbed. So if n increases, the denominator will increase, and as denominator dominates here, so overall daily will decrease. So daily will decrease while increasing the n, that means the energy gap between the successive energy level, the energy gap will decrease while the when the n is increased. That means the daily between 2 1, that means energy level 2 and 1 should be greater than 3 and 2. Okay. So let me stop here in this part. We'll discuss more about these things in the next part. Thank you for paying attention.